So this is question 17. Given that x, y, z are real numbers, that satisfy the two equations here. The sum is equal to 60 and xy minus z squared is equal to 900. With this, what is the maximum value for the modulus of z? Here, x plus y is equal to 60 minus z, and xy is equal to 900 plus z squared. Since xy are real numbers, we know that x minus y squared is greater than or equal to 0. But x minus y squared can be written as x plus y squared minus 4xy greater than or equal to 0. X plus y is equal to 60 minus z squared minus 4 of xy. And from here we can form a quadratic inequality in z. So for z squared, there's a 1 here and there's a negative 4. So total 3z squared, and this will be less than or equal to 0. For z, this is negative 120. So it become plus 120z. For constant, this is 60 squared, which is equal to 3600. And this is also 3600, and they will cancel off. So this is our quadratic inequality. So this means that z plus 40 less than or equal to 0. And therefore z is in between 0 and negative 40. Since z is in between negative 40 and 0, and therefore the maximum of the modulus is equal to 40. So 40 is the answer for question 17.